So substitution is another method for us to be able to solve systems. And systems are just when you have two equations and you want to find out what x value and what y value work for both of them simultaneously. And there's only one answer for these. So we are going to look at substitution right now. So with substitution, the idea is just like when you have a substitute teacher, you're going to replace something. So for example, maybe I'll replace this x with something else, and I'll put that number in there, or I'll put whatever that is, so that I can have just one variable. See, that the fact that we have two variables in an equation makes it impossible for us to solve with just one equation. And so by replacing one of the variables or substituting in for one of the variables, then we're able to get it down to just one variable where we can solve for it. Now, when you're looking for a substitute, the first thing you want to do is find what I call a clean variable. And so if we look at this first equation here, we see that there's a 2 in front of the x. That makes it a not clean variable. When I talk about a clean variable, I'm talking about a variable that doesn't have a number in front. So here our clean variable is the y value. Now, none of the other ones are clean, so we'll just work with the y value here. Sometimes you have more than one to choose from. Sometimes it may even already be there for you to be used right away. But if not, we have a clean variable. So what I'm going to do is I'm going to draw an arrow over and I'm going to rewrite it. And I'm kind of picky about how I do this. I like to have my visual arrow there to tell me what equation I used so that I don't mistakenly use that same equation later. And so I rewrite it, and then my goal is to get that clean variable by itself. I want to leave that one alone. I want to get rid of the 2x. So I subtract 2x. Whenever you get rid of a full term, you either add or subtract. So now I have y equals, and then on this side, notice the 1 does not have an x on it, so I can just write 1 minus 2x, because that's exactly what I have there. Okay, so I have 1 minus 2x. That's my substitute. This is what I'm going to replace the y with on the other equation. So my other equation on the bottom here, so here's my bottom equation. I have an x and a y. Well, I know now that y is worth this. This is what its value is. So I'm going to take this and I'm going to plug it in for y right here. So I'll rewrite it. So you'll see I have the 2x still, plus I still have the 2 in front of the y. Now this 2 is being multiplied times the y, so now I'm going to multiply it times the substitute. And I'm going to replace the y with its substitute. So I'm going to put a 1 minus 2x in where the y was, equals, and then it equals negative 2. So now I have this equation, and notice, like I said before, I only have x now. I only have one variable, so now I can solve this equation like I would earlier in the book. So we have 2x plus, I have a 2 in front of the bubble, so I need to distribute the 2. So I get 2 minus 4x equals negative 2. And then I have a 2x and a minus 4x. They're on the same side of the equal sign, so I'm going to put those together. Plus 2 equals negative 2. And then I just keep on solving. Subtract 2 from both sides. Negative 2x equals negative 4. Divide by negative 2. And I get that x equals 2. So I know part of my answer is that x equals 2. But remember, I have to find x and y for my solution here. So now I need to find the y value. Now there's a variety of things you could do. You could go back here and you could plug in 2 right here and solve this equation. Or you could plug in 2 right here and solve this equation. It doesn't really matter. What I like to do is I like to go to my substitute and I like to plug in 2 there, because guess what? It's so much easier to do this math than it is to solve any of these equations. So I'm going to go back and I'm going to plug in 2 for the x value, since I know that's what it equals now. That's what y equals. And so now I get 1 minus 4, and 1 minus 4 is negative 3. So now my y value is negative 3, and I have officially solved this system of equations. Okay, let's check out another one that's a little bit tougher. So when it gets a little bit tougher, what it means is I don't have any clean variables. You'll notice here that I don't have, I have a number in front of x, I have a number in front of y, I have a number in front of x, I have a number in front of y. So we don't have anything that obviously sticks out as a clean variable. So instead I got to think ahead a little bit. Now whatever number's in front of a variable, if I was to solve for that variable, I would have to divide by that number. So let's say I was going to solve for x here. That means I'd end up dividing by 4. That means the 2 gets divided by 4 and the 6 gets divided by 4, which means I have a fraction, which I kind of want to stay away from. But if I solve for the y here, and I divide by 2 and I divide by 2, that's okay. Everything's divisible by 2, so that's the one I'm going to go for. So I'm going to draw my arrow. Remember, the whole point of the arrow is to help me know what equation did I use to find my substitute. Because once I've found my substitute, I want to plug it into the other equation. So that arrow lets me know which one's the other equation real easily so I don't make that mistake. Because if you do that, make that mistake, you're going to get something that doesn't make any sense. So I'm solving for the y, which means I need to move the 4x over. So I'm going to add 4x to both sides. Now we have 2y equals 6 plus 4x. Then I divide everything by 2, everything gets divided. And I get y equals 3 plus 2x. So that's my substitute. I'm going to take that and I'm going to plug it in for the y on the other equation. Notice I don't have an arrow on that one. So I rewrite that equation. I've got 6x minus 4 times, and then I put in my substitute, 3 plus 2x equals negative 14. Okay, now I have to multiply through by that negative 4. And so we get 6x minus 12 minus 8x equals negative 14. I'm going to put together my like terms. Now I have 6x minus 8x, that's negative 2x. I still have my minus 12 equals negative 14, and then keep on solving. So then I'll add 12 to both sides. And I get negative 2x equals negative 2, divide by negative 2, and I get x equals 1. Now that's part of my solution, so x equals 1. Now I got to find the y value, and so I'm going to go back to my substitute, remember from the last problem, and I'm going to plug in 1 for my x value. And I get 3 plus 2, which gives me 5. So my y value is 5. Okay, this is my answer. Now, that's pretty much everything for substitution. I just want to point out that for both of my problems, I ended up getting my substitute, my y, getting to equal something. And I just want to make sure you understand that you could also have done the x. The x is just fine. It's just in these two problems it happened to not be the one that I picked.